All right, let's dive in. Today, we're going to unpack a quest to solve a really common, but, surprisingly complex problem in smart home tech. And believe it or not, it all kicks off with a super simple goal: to stop killing houseplants. So the whole journey starts with a problem I think we can all relate to. You forget to water your plants. Again. The obvious solution? A wire-free, smart little gadget for your plant. But hang on, that just creates a whole new chore, right? What's the point if you just swap forgetting to water the plant with forgetting to charge the plant's sensor?
And this is really where our story takes a turn. Because this whole thing, it stopped being about saving plants. It became about tackling one of the biggest, most annoying challenges in the entire smart home world. How do you make a battery that can last for years, not just weeks?
So let's take a look at how this all began, with a plan that on the surface seemed almost, deceptively simple.
The initial plan looked absolutely perfect on paper. Seriously, you take a super energy-efficient little brain, the NRF528040 microcontroller, you pair it with a reliable capacitive moisture sensor, one that won't just corrode in the soil, and you power the whole thing with a lithium battery. Slap them together, and you're done. Problem solved, or so it seemed.
So the first big decision was the battery. And honestly, lithium was a no-brainer. Look at this. To get enough juice for the microcontroller, you'd need 3 clunky alkaline batteries. But a single, much smaller lithium cell, it gives you more than enough voltage. On top of that, lithium just packs way more energy into the same space, and it can handle those sudden power spikes from the radio, which is something alkaline batteries are really bad at. It felt like an easy choice.
With all the main parts picked out, you'd think it would be smooth sailing from here. But this is exactly where that simple plan just slammed into a very complicated reality. It hit one major roadblock after another.
I mean, really, what could possibly go wrong? He thought he had it all figured out, right? A great little computer, a clever sensor, the perfect type of battery. But as we're about to see, the world of do-it-yourself electronics is rarely that simple.
And boom, here's where the wheels started to come off. First, the microcontroller could charge a battery safely, sure, but it had zero protection to stop it from draining that battery to a dangerously low voltage. That could totally ruin the battery, or even worse, start a fire. Second, that smart soil sensor, turns out it had its own little brain that was always on, just constantly drawing power, killing the battery in just a few days. And finally, and this is the real kicker, the solution to that first problem, a battery with a protection circuit built right in, was just a few millimeters too long to fit in any standard battery holder.
This basically created a classic engineering catch-22. The microcontroller needed a protected battery to be safe, but the protected batteries literally wouldn't fit. The project was totally stuck.
So just when the project seemed totally doomed, and that dream of a self-watering plant sensor was pretty much fading away, something totally unexpected happened that changed everything.
After hitting a total dead end, the creator pretty much accepted his fate. If off-the-shelf parts weren't going to work, well, he'd just have to make his own. And that meant diving headfirst into learning a completely new, incredibly complex skill: custom printed circuit board, or PCB design. And then, just like that, in this incredible stroke of good luck, a company that actually specializes in making custom PCBs reached out completely out of the blue. They offered to sponsor the whole project and manufacture the custom boards for him. What was a massive project-ending roadblock just turned into a clear path forward.
Okay, but getting a sponsor, that was just the first step. Now he had to actually design a working circuit board, and that, of course, brought on a whole new set of challenges.
So the custom board was built around these 3 critical little chips, or ICs. The first one, a voltage regulator, gives a nice stable 3.3 volts to the whole system. The second is the protection IC. This is the hero that prevents overcharging, over-discharging, and short circuits. And the third is a charging IC, which makes sure you can safely charge the thing from a USB port.
But even after getting the new custom boards made, things still didn't work. After hours and hours of banging his head against the wall, he realized he'd made a simple, classic mistake. He forgot a pull-up resistor. It's this tiny little component that helps the microcontroller get a clean signal from the sensor, and without it, nothing. Which led to this pretty frustrating moment of self-realization. So after he finally found a software fix for that hardware mistake, he hit the biggest wall yet. That ultra-low-power NRF52 chip, the very first part he chose because it was so efficient, well, it wasn't fully supported by the ESP Home software he wanted to use. And that meant the critical deep sleep modes were unusable, and the project's #1 goal, multi-year battery life, was, once again, dead in the water.
So with the original plan completely in shambles, a last-minute pivot to a totally different chip led to an unexpectedly fantastic result.
Okay, so the new plan was to swap in a different microcontroller, the ESP32C6. Now the key here was to absolutely minimize the time the chip spent awake. By tweaking the software with things like a static IP address and a fast Wi-Fi setting, the device could wake up, connect, send its data, and go right back to sleep in just a few seconds. It was sipping the absolute bare minimum of power. So, after all of that struggle, the design flaws, the custom boards, the software nightmares, what was the final estimated battery life from a single charge? A pretty stunning 1.7 years.
And this table right here, this shows you exactly how he pulled off that incredible battery life. You can see the device is only fully active for about 3 seconds every hour, pulling around 100 milliamps. For the other 59 minutes and 57 seconds, it's in a deep sleep, drawing a minuscule 22.5 microamps. That tiny, tiny sleep current, that's the secret sauce to its amazing longevity.
This quote just perfectly captures the core lesson of this entire project. In theory, on a whiteboard, engineering can seem so clean and perfect, but in the real world, it's almost always about clever workarounds, embracing imperfection, and sometimes, as he says, using a bit of bodge and jank just to get the thing to actually work.
And really, this victory is just one step on a much longer journey. As software gets better and starts to support more efficient chips and new low-power ways to communicate, a 5-year battery life for a smart home device isn't just a crazy dream anymore. It's gonna be the expectation. The smart home battery problem isn't totally solved yet, but this proves we are getting much, much closer.